an introduction to the technology of regenerative power. In fact, any elevator nowadays is composed mainly of a rotating machine with ropes, set of ropes laying on the machine, on the pulley of the machine. The pulley of the machine is called, in the lift terminology, traction sheave. From one end, the car is connected to the cabin, and from the other side, the ropes are connected to the counterweight. In order to have a proper and realistic stability of the mechanical system, we should have the counterweight weight equals to the car, empty car, plus 50% of the rated load, which means if we have a lift with a rated load of 1,000 kgs, when the car is loaded with 500, it will balance with the counterweight. What does it mean on the machine level? In case our full loaded car is traveling upwards, or the empty car is driving downwards, the machine is consuming energy, thus it's working as a motor. From the other side, in case the full loaded car is traveling down, or the empty car is traveling up, the machine is generating power. Traditionally, any VVVF drive elevator, what will do with the generated power? It will dissipate them in a resistance through a heat. What if we use this energy back into the grid? This is the regenerative power of lifts. Now, this information will be detailed by Connie. I invite Mr. Ali Asad. Mr. Ali Asad is a mechanical engineer, and he has 11 years of experience in a lift industry. Currently, he is the operation manager with K Systems. K Systems is representing Kony lifts in several countries, of course in Lebanon, and sorry, I have to read them because they are too many. Beside Lebanon, it's in Benin, Cameroon, Central Africa Republic, Congo Brazzaville, Côte d'Ivoire, Democratic Republic of the Congo, Equatorial Guinea, Gabon, Ghana, Sierra Leone, and Togo. Please.
I will speak here.
It's yours.
Okay, yes. It's more than you. Yes, I have. Hello, everybody. I want to thank you for giving us the opportunity to introduce our regenerative drive system. My presentation is divided in 6 slides, including a video. First slide. Kony in brief. Kony is a global leader in elevator, escalator, and automatic building doors industry. With the help of authorized distributor like our company, Kony provides service and helps customers to achieve their eco-efficiency goals in every phases in the building life cycles, from designing and constructing the building, maintaining and modernizing it. The Eco Disc machine. Sorry, I believe there is okay. The never-ending increase in the number of population has contributed in the forming of megacities in several countries. With numerous geographical and weather constraints, Megacity's horizontal expansion started shifting vertically, creating more space by simply having taller building. Through a series of 8 global research and development centers, along with 7 global production sites, KONI is determined to cope with these urban and space demands by customer expansion, by being able to further push the boundary and exceed customer expectation with its state-of-the-art technology and advanced solution that were the missing link for tackling the urban growth problem. The EcoDisc motor. The EcoDisc is a gearless housing machine made by KONI during 1996 with the introduction of the world's first machine roomless elevator system. It's a rotational linear motor combined with the synchronous axial technology and permanent magnet. The EcoDisc machine has many benefits such as superior material and energy efficiency, using no oil at all. With its reduced friction gearless construction, the machine uses only half the power needed by traditional system. Moreover, the machine weight was cut to half with one moving part. It's well known for its smooth and quiet operation. In 2012, this machine has totally redesigned, providing several advantages. Again, the new innovative copper winding system reduced the amount of the energy lost as heat, making KONI elevator even more energy efficient than before. In number, 70% less energy than conventional elevator solution, with 30 to 40% lower peak starting current. In addition, the new motor control system and the brake provide a smooth and quiet ride, while the more compact design frees up space to satisfy urban expectation needs. The regenerative drive system. KONI is the pioneer of eco-efficiency in elevator industry. With the available advanced elevator solution and technology, larger opportunities have been created to save energy and control its consumption. KONI provides since 1991 solution for an energy-hungry world, and alongside EcoDisc machine, the regenerative drive takes advantage of the motor when its synchronous speed is less than its rotor speed. In such a situation, the direction of the torque opposes the direction of the motor rotation. This happens when the elevator goes up with a light load and down with a heavy load, or in another word, when gravity is doing most of the work. In addition, anytime the elevator slows down, energy is created and captured by the regenerative drive. The KONI drive uses modulated line bridge technology, and hence, when the KONI EcoDisc motor acts as a generator, the braking system generates clean power with low harmonic distortions, making it convenient to be linked back to the building electrical network that can be used elsewhere in the building or drive another elevator. Simple simulation and approach that further explain the regenerative drive concepts.
Today, more and more buildings around the world are being designed and built using energy-saving construction methods. KONI's eco-efficient solutions are dedicated to supporting this trend. With its continuous innovation and industry-leading technology, KONI responds quickly to ever-changing market and customer demands. Our revolutionary EcoDisc hoisting motor and regenerative drive system continue to push the boundaries of eco-efficiency. So how does this drive capture energy for reuse around the building? The car and counterweight run up and down the elevator shaft, and the hoisting machine drives them in opposite directions. The car weight is usually different from that of the counterweight, depending on the number of passengers inside the car. When a fully loaded car starts to move, the motor uses electric power to accelerate the car to full speed. Once the elevator reaches the correct speed, the motor needs to continuously impose a corresponding electromagnetic braking force in order to overcome gravity and ensure the speed remains constant at the nominal speed of the elevator. It's just like a car driving downhill. When it reaches the required downhill velocity, the brakes are applied continuously to keep the speed constant. When the electromagnetic braking, as the car approaches the destination floor, the elevator decelerates and the motor continues to generate energy. This energy can then be reused elsewhere in the building. The greater the operation speed and distance traveled, the larger the weight variation between car and counterweight. Or the more frequently the elevator is used, the more energy is regenerated. In conventional elevators, the braking power regenerated from the motor is lost as heat in the power resistors. KONE's advanced energy regenerating brake technology works in a similar way to the control systems of electric and hybrid vehicles. The result is an efficient and reliable elevator that both provides passengers with a comfortable ride and enables energy savings of between 30 and 55%. KONE's energy regenerating braking technology can be used with all our elevator solutions. Our unique solutions are used in eco-efficient construction projects worldwide. The advanced EcoDisc hoisting motor and regenerative drive, as well as many other patented features, have helped KONE partners worldwide achieve green building certifications like LEED and BREEAM. What's more, our innovations and creativity have gained both widespread praise and several international awards. KONE, dedicated to people flow.
In conclusion, sorry. It's okay. This is the last one, yes. In conclusion, so imagine in a huge commercial center with a remarkable traffic holding numerous elevators. The KONE elevator and escalator can support in generating power for the building's lighting, air conditioning, and/or elevator or escalator operation. So, helping the lift to reach the 30% objective for return power, or even go beyond that in certain situations. KONE is even pushing the boundary to support this anti-power consumption drawback by offering further innovation day by day. For example, in the testing tower in Titori, Finland, and in Kunshan, China, reveal unique innovations such as a super light traction rope, which had to serve higher travel. It's called KONE Ultra ropes. This type of ropes helps to save 15% out of the consumption energy for 400-meter travel, reaching up to 40% power saving for the travel reaching 800 meters. Moreover, minor eco-efficiency technique further enhance the power saving process for elevator, from using LED lighting fixture to advanced standby solution and group control, and also KONE Ultra ropes. The building is surely going to be a witness on a whole new experience that will be electrically, technically, shock any building manager. KONE elevators are now considered as an unexpected source of energy, defying and overcoming all expectation. Thank you for all for your attention. Merci.
take in the program. Qu'est-ce qu'il y avait là? Il y avait there is something inside the file. Sorry.
Sorry about that.
Toi, tu reprends, mais avec laquelle? La 51?
Yes.
Ah, mais c'est pas vrai, ça. Qu'est-ce qu'ils m'ont fait?
Okay. Before start, as an introduction to our next presentation, just like a small information about how the VVVF system function in the lift. Conventionally, it's made of a rectifier, rectifying the AC to DC current, and then the inverter will be converting the DC to AC current. What if we replace the DC rectifier into a battery? Of course, we are switching to another type of work. Now, Gen 2 from switch will be, Gen 2 switch from Otis will be presented by Mr. Sarkis Abdallah. Mr. Sarkis is a mechanical engineer with 36 years of experience in the lift industry. Actually, he is the sales manager at Otis Lebanon. Otis Lebanon is taking the operation in Lebanon and in Jordan. Mr. Sarkis.
Good morning, everyone. As we know, nowadays, the lift industries, their main concerns is to have a green technology, renewable energy, and a low consumption. Therefore, Otis has invented a new product called Gen 2 switch. The Gen 2 switch runs on a 220 volt 50 hertz single phase, consume 500 watts and 1.5 amp, which is less than a microwave oven. It's like a plug-in domestic appliance, safe to use. It works as a normal extended period of time on the power supply from main dues to the UPS online feature and generates power. On the normal mode, the battery supplies power to the motor and regenerating. So when batteries are full, the energy is consumed in the braking resistance. When power is cut, the battery will take place and supply the power to the motor and can take you up to 100 trips. We're going to see a short movie about the Gen 2 switch.
Otis presents Gen 2 Switch, the elevator that points the way to energy independence. Gen 2 Switch is the first Otis continuously battery-powered Gen 2 elevator. And like any appliance, it connects to the electrical grid via a simple 220-volt outlet. There is no more need for special three-phase power or for a machine room. Installation of the elevator is faster than ever. The results are clear: considerable saving of money and time, and a secure installation schedule for all your building or renovation projects. Gen 2 switch needs only 500 watts to operate. Less than a microwave oven or a hairdryer. How is that possible? Thanks to Otis's innovative thinking. Gen 2 switch includes a battery pack inside the elevator hoistway and an exclusive regenerative drive system called Regen Drive. The car descends by the force of gravity alone at full load, and also when it ascends empty or under light load. In such situations, the car uses gravity, allowing the Regen Drive module to produce energy and return it to the batteries. This technology reduces power consumption by up to 75%. Gen 2 switch is a smart elevator. It can adapt its speed in real time depending on the car load, the battery potential, and the trip being made. In case of a power blackout thanks to its batteries, Gen 2 switch can continue to operate on its own in total safety for approximately 100 trips. Gen 2 switch was designed based on a unique technology using flat, steel-reinforced polyurethane belts in place of traditional cables. The belts make the elevator's operation silent and, most of all, reliable. For optimum safety, Gen 2's unique pulse system monitors belt's condition 24/7. And lastly, Otis has not forgotten a single detail. All Gen 2 switch machines have LED lighting, combined with advanced standby features, reducing energy consumption up to 80% compared with fluorescent tubes. The use of battery power and a regenerative drive system, combined with the Gen 2 technology, results in savings of annual energy consumption compared to conventional elevators. Its battery storage capacity makes the Gen 2 switch elevator fully compatible with renewable energy sources such as solar and wind. But while it's notable for its energy efficiency and the savings it can make possible, Gen 2 switch has not neglected the style, performance, durability, and comfort you expect of an elevator. To sum up, the Gen 2 switch elevator meets all of your requirements regarding environmental quality and guarantees you savings on building costs and energy bills. With Otis, innovation and energy performance are not options. With a commitment to continuous improvement, reducing energy usage and enhancing performance, it's not surprising that Otis elevators, escalators, and moving walkways are a part of many of the world's most well-recognized and significant buildings across the globe.
We have to know that the Gen 2 switch can take the maximum load of 630 kilos and the travel of 21 meters or 7 stops, the maximum of 7 stops. And the speed will be 1 meter per second maximum. Thank you.
Thank you, Mr. Abdallah. Okay. Now, our third presentation will be by Mr. Abdu Ashkar.
Mr. Ashkar.
Okay. Now, just to, as an introduction to the presentation of Mr. Our next presentation by Mr. Abdu is about the variable speed elevator from Mitsubishi, which means we have an elevator with multiple rated speed. Mr. Abdu, please, from Mitsubishi. Mr. Ashkar has over 33 years of experience in elevators field. He is an electrical engineer. And actually, he is the general manager on the corporate level for Mitsolift. Mitsolift is present as a joint venture with Mitsubishi to perform the operation in Lebanon, in Greece, Cyprus, Syria, Jordan, Ghana, Nigeria, Cote d'Ivoire, and recently in Malta. Please.
Thank you, Mr. Sur, for your introduction. Good morning, everyone, and thank you for your presence. You can have a 10 minutes break if you want now. Okay, so variable speed. Variable traveling speed for elevators. Let me start to explain what does this feature mean. Mainly in elevators, two main factors which determine the elevator specification are the rated speed and rated load. So the main component like traction machine and inverter are mainly calculated based on those factors. So means that the car cannot run faster than its rated speed and cannot be loaded more than its full capacity. But with VSE, variable traveling speed for elevator, it will be possible to make it run faster than its rated speed. And this is new in elevator technology. Let me ask three questions. Why do we need VSE? The second question, how it works? And the third question, does it really contribute in saving energy? Now, how it all started. As Mr. Sur explained, we have the mechanical power of the traction machine depends on two major items, which are the force and the speed. So if the traction machine or the elevator is not tearing the full power, the full load, means there is unused energy which we can benefit to increase the speed. Increasing the speed meaning responding faster to hall and car calls. So reducing the average waiting time and the car traveling time. So we'll be in need of less unit to cover a building traffic study. How it happens this? How can we do it? Now, the number of passengers inside a car determine the car and counterweight balance ratio. When a car is well balanced, that means there is unused power, like I explained before, which we can benefit to increase the speed. But how can we increase speed? In the elevator today, we have AC machines. So by increasing the frequency, the machine will absorb more current, but for sure not more than the maximum current, which make it running faster, and thus reducing the average waiting time. If we look to this graph, where we have on the x-axis the percentage of the car load, and on the y-axis the traveling speed. So when the car is barely loaded or fully loaded, means the traction machine is using its full force, so we cannot increase the speed. And the elevator will be running on its rated speed, which is in our case 1.6 meters per second. But when the car starts to be loaded or less loaded than the full load, means that the balance is changing now. Changing, that means we start to have a little bit of energy which we can use it in increasing the speed. When we reach between 40% to 60% of the rated load, that means the car is well balanced and we have a lot of energy which we can benefit from. In our case, we will be running on 2.5 meters per second, in spite that the elevator we bought it with the specification on 1.6 meters per second. And it will be more than 50% from the rated speed, 2.5 compared to 1.6. As a result, we will have, according to Mitsubishi Electric simulation and calculations, we'll have a reduction of 12% reduction in waiting time, as well as 25% reduction in car traveling time. Now, let us watch a short video which explains in a simple way how this feature works.
Variable Traveling Speed Elevator System. Are you satisfied with existing elevators? Have you ever been irritated by long waiting time? Or have you ever been frustrated by the slow speed? It may be solved by increasing the number of elevators or by changing the elevator speed faster. However, it requires drastic changes, such as upgrading the traction machine and power supply, etc., which will end up with a high cost and require larger installation space. How do you solve such problems with a limited budget and space? Variable Traveling Speed Elevator System can help you. Variable Traveling Speed Elevator System can increase the maximum speed. These are the conditions to activate the system. When only a few passengers are in the car, or many passengers on board, the car and the counterweight are unbalanced. Then the elevator runs at the rated speed. In unbalanced weight condition, the traction machine uses its full power to run the elevator at the rated speed. When the car and the counterweight are well balanced, Variable Traveling Speed Elevator System is activated. In well-balanced weight condition, the elevator does not need full power to run at the rated speed. Utilizing such unused power, the elevator can run faster than at the rated speed. This is Variable Traveling Speed Elevator System. This system allows the elevator to run 1.6 times faster than the rated speed. Waiting and traveling time can be reduced by 12% at maximum. Mitsubishi Electric's unique technology, the Variable Traveling Speed Elevator System, provides efficient and comfortable vertical transportation through optimum use of power for energy conservation.
So, I'm ready for your questions at the end of this session. Thank you very much. Thank you for your attention.
Thank you, Mr. Ashkar. Now our next presentation, I can say it's like a small step into the future of the elevator. And it's definitely, as you will see, is going to change all our concepts regarding this matter. To start with, just a rotating machine, we all know, is consisting of a rotor and a stator or excitation. What if we cut them, we straighten the excitation and the stator. We fix the stator on the rails, and the excitation, we fix it on the machine, on the cabin itself. We'll have a ropeless lifts. With a ropeless lifts, with a lift without ropes, we are going to have multi-possibilities. I invite Mr. Zahia. Mr. Sharbil Zahia has 9 years of experience in the lift industry. Actually, he is the sales manager at Trust for Elevators. Trust for Elevators are the distributor of Thyssen lifts in Lebanon and in Iraq. Thank you.
Thank you. Thank you. As Mr. Habib said, I will be presenting the ThyssenKrupp multi-technology, which is a new innovation about elevators. Usually, in normal cases, each shaft contains one elevator, as everybody knows. But using multi-technology, we are able to put several cabins, multiple cabins, in one shaft in a loop system. These cabins will work on rails and can go vertical and in horizontal direction. This is a new technology that will transform the way people use elevators inside buildings. In this slide, we can see the tallest buildings in the world. As you can see, most of the buildings have 500-meter border. This 500 meter is an important border for conventional elevators, because at this height, the ropes become very heavy and might even collapse under their own weight. The advantage of ThyssenKrupp Multi is there is no more ropes anymore, so there is no more limit in height or architecture. If you look at this tall building in China, you can see the massive core the conventional elevators are using, and the small usable area for the building remaining. Also, the advantage of ThyssenKrupp Multi is that it saves up to 40% more shaft space. Therefore, you will have more usable area in your building.
One?
No, the other. No, yes, not the slide before, the previous one. This one, yes. As Mr. Habib previously described, ThyssenKrupp Multi works on linear drive technology, which is based on the magnetic levitation principle, which is similar to the trans-rapid train. The cabins work through induction, through magnetic induction, coming from the rails to the cabins. The active part is on the rails, and the passive part is on the cabin. Therefore, energy is consumed only where the cabin is moving. ThyssenKrupp Multi is being tested and certified at the moment. In this slide, you are watching the exchanger mechanism. The exchanger role is to change the direction of the cabin from horizontal to vertical and from vertical to horizontal. So you are looking now at the mechanism of how it works. Also, the cabins are made of carbon fiber in order to decrease the weight of the cabin and to use less energy in order to be able to move them. Each cabin is equipped with a battery system. In case of electricity cut, the battery will bring the cabin into the level in order to rescue the passengers and open the doors. Also, another feature of ThyssenKrupp Multi is that the power generated from a cabin going down will be directly transferred to another cabin going up. Each full cabin going down will generate enough energy to move an empty cabin going up. Now here you can see in this animated slide how Multi can work. This is called the peak mode since we are using all the cabins inside the building. But also Multi can work in off-peak mode. What if we do not require all the cabins to be used? In off-peak mode, several cabins which are not required to be used are parked in several places in the building, and only the ones required are being used in the building, as you can see in this animated picture also. What if a cabin is malfunctioning in ThyssenKrupp Multi? In case the cabin, as you can see, is malfunctioning, the other cabins will use alternate routes in order not to stop the whole system. Okay, so each cabin will use another exchanger in order to turn around the malfunctioning one. Multi can also be used in subway mode, as you can see here, in case the building is linked to the subway. So the cabins will go down to serve the passengers, and then they will continue their service inside the building. Also, in case the building is equipped with a heli stop, the cabin will go up also to serve the passenger, and then it will go down and continue its service. So as a summary, Multi will reduce the elevator footprint from 30 to 50%, because here we are not using ropes anymore and we don't have counterweight, and also we are decreasing the shaft size. The peak power consumption will be reduced up to 75%, since we don't have anymore any sudden power input from a huge rope-driven elevator. Of course, we will effectively use the wasted space, and we have no more limit in heights and structure. Now we will see an introductory video about Multi from ThyssenKrupp.
1854, the birth of the elevator. This invention changed the way we live. One cabin, in one shaft, on one rope, traveling up and down. A principle that hasn't changed for 160 years. 2003, the twin elevator changed the industry. Two cabins, independently in one shaft. In the future, more and more people will live in megacities. Today, building development is constrained by the forms of mobility available. A revolution is required. We started to reinvent the elevator concept. What if we were to omit the rope and have a direct drive as part of the elevator cabin? What if we were to provide more than two cabins in one shaft and let them circulate in a building? What if we were to invent a groundbreaking system enabling the cabin to move not only vertically but also horizontally? No more limits in height, shape, and mobility. There are multiple possibilities. And that's why we call it Multi.
Thank you.
I want to thank the speakers, and now I think you have several questions, so they are ready to answer your questions. That's why they are still on the stage. Anybody has any question?
Yes, please. The Thyssen new technology, probably the installation is more critical because it should be really aligned than the old generation system. Do you have an idea of how much more would cost an 8-floor system with an 8-floor system? I mean, how much more we are talking in money?
Yes, this technology is, if you want to compare it to the conventional elevator, it is more costly. In the small buildings, we don't have an idea about the price since it is being tested at the moment. It is only installed in Rotwell Test Tower in Germany, in the test tower of ThyssenKrupp. However, this technology is used in mega structures. In mega structures, for example, in an airport, you can replace the shuttle train, and you can replace elevators, and you can replace escalators. Therefore, you will be, of course, saving money since you are changing all these systems and putting them into one system, which is multi. So the advantage of multi is in mega structures, not in small buildings for the moment.
Thank you. Any other question?
Behind.
I have a remark about regenerative braking. When we are working in regenerative braking, the extra mechanical power is transformed into electrical and absorbed by the building. So if the load is not large enough to absorb this extra power, and if the generator is supplying the building or the load, so this extra power will enter into the generator and it will cause overspeed, or the generator become unstable.
Sorry, but normally with the elevators, always it's just for a short time, and you have plenty of things. At least you have the lighting inside the car, you have definitely other lightings. It's not something like theoretical, you have only a generator.
No. Maybe the load is not large enough to absorb all this power, and the extra will enter into the generator. You are connected asynchronous generator to asynchronous generator. Okay. In my opinion, in general, if we are working in regenerative braking, in my opinion, we have to use reverse power in the generator. So if the generative braking is trying to enter power to the generator, so you have to switch off or disconnect.
But regarding these systems, definitely it's not like done by normal engineers. It's normally done and all are certified. So if you are talking about the generator as itself, it should have protection. It's a different story. But for the elevators, they have been tested, of course, for such things, and they have been certified. And regarding in the elevator technology, it's something like black boxes. Even the distributors are not able to answer
the regenerative braking can test or can check if you have extra power that cannot be absorbed by the, maybe this extra power is reflected as overvoltage, for example. Is there a protection system in the regenerative braking that detect the load cannot absorb this extra power?
Yes, of course there is a protection. You know, when you are regenerating power to the buildings itself, it's regenerated through our controller which protecting the installation as well as protecting the elevator from the compacts of power. If the power, you don't consume it, of course, if you will not consume it.
I don't have enough loads that
absorb it. It will be burned.
How?
Through resistance.
So if we have malfunctioning the resistor,
so
if we have risk to
the elevator stops. We have a signal that there is malfunction.
Okay, so
of course, it's well protected. Of course, yeah. But if you don't consume it, it will be burned. It will not be accumulated in batteries or something like that.
Thank you.
Thank you.
Thank you. Next question. That's all. No, good.
Sorry?
Thank you. Yes.
Concerning.
Thank you. This is from the speakers. Any question? No.
Yes, one.
Yes.
Oh, sorry.
The last.
Concerning safety system for Thyssen, in this new technology, is there any safety gear, and what is the appropriate standard or norm for this kind of elevators?
Regarding the standards, I will answer regarding the standards. Regarding the standards, always, whenever there is any new invention in the elevators, you have 10 years of patents. And then they will not cover by any standards. They will be covered by the EC type examination or EU type examination certificate for this specific type of lifts.
Okay.
Like exactly what happened with Kony when they invented the machine roomless back in 1994, till the year 2004, the EN 81-1 mandated to have a machine room. And the Kony were installing the lifts and several other companies after that, based on the EU on the directive,
okay,
and based on EU type examination certificate. Regarding the safety gear, I think
we have two safety brakes in this case. We have one called safe brake and one called fail safe brake. Usually the safe brake captures the cabin in order not to move. And in case the safe brake do not move, do not work, the fail safe brake will then will then stop the cabin from moving.
The fail safe brake is also installed on the cabin?
Yes, yes, both are installed on cabin.
Okay, thank you.
Thank you. Any other questions?
It was only for you, your answer.
Okay, I thank you, the speakers, and on behalf of all the audience, we thank you. Thanks.
Thank you very much.
Now,
And
our
also
next session.
2 seconds. Only my thanks to Habib, because the coordination was a big job with the 4 speakers from Kone, Mitsubishi, Otis, and Thyssen. And thank you for this coordination.
Thank you. We thank again, Sia. Now, our next session is for the students who have worked hard for the last 1 month and some for the last 3 or 4 months to present their projects. I invite them, I will call them by the names, and I invite the jury to be just in front here. The first group B, Mr. Muhammad Nazir and Mr. Muhammad Nazir. Can you please come? I just would like to ask you to know who is your supervisor and which university are you?
Okay. Our supervisor is Dr. Shadi Nohra from Beirut Arab University.
Thank you.
You are okay. You? Ah non. C'est pas possible ça. Tu m'as encore changé tout à l'heure, j'ai pas fait bien. 61. Sorry.
Take your time.
I will do all of them because I'm not with the right of the tu me diras ce qu'il faut changer. I have yet a new number that I will put it just later. We begin with you. Hi. Sorry for that. That's cool. Thank you.
Thank you.
I leave you.
Good morning, everyone. My name is Muhammad Nazir, and my colleagues Rawat Kabbara and Abdelghani Lawzi will be presenting you control of hydropneumatic energy storage system, supervised by Dr. Shadi Nohra. First, we'll start off with the motivation for our project, some existing solutions, our solution, and the demo of our prototype, its block diagram, then our added value, our contribution, and finally we'll talk about safety, standards, and constraints. So a study conducted by the Lebanese Center for Energy Conservation stated that there are 0.65 tons of CO2 emitted for each megawatt hour generated in Lebanon. So this high value, it is mainly caused by the power plants. And another study revealed that in the area surrounding these power plants, there is a high number of diseases. To add to that, another study by the American University of Beirut stated that the daily exposure to cancer is increased by 33% by just operating the diesel generators for only 3 hours per day in Beirut. So as we can see, the threat of pollution in Lebanon is very real. A solution to the first problem is renewable energy, of course, and these need suitable energy storage systems. The most common one is batteries. Batteries have limited duty cycles. They are difficult and costly recycling and have problematic waste. Of course, better batteries exist, but they have a high cost, which is a limitation in Lebanon's market. So our solution is cheaper, has a long lifespan, and is totally eco-friendly. And to add to that, it solves the second problem of diesel generators, the problem of incomplete combustion in diesel generators. Here's a little video of our demonstration. Solar panel supplying Summerlnd Leo converter, characterized by its robustness and low noise. The duty cycle for this controller will be controlled by a maximum power point tracker microchip controller to track the maximum power point. Now, in our demo, we will use a function generator of around 40% duty cycle to simulate this performance as we finalize the code for the algorithm, which is perturb and observe. The input voltage, as we can see, is around 20 volts from the solar panel. The output after the Leo Super Boost converter is 264 volts, which will in turn feed the 3-phase PWM inverter with V over F control. Now, as we can see, we can control the frequency and voltage thanks to the PWM and V over F control. Okay, so as we just stated, the photovoltaic solar panel will feed a cylindrical air compressor, which will pressurize air and inject it into a tank, which will force the water to flow into a second tank. This will be the storage phase, which is shown by the animation above. And when the sun sets down, for example, a closed-loop proportional control implemented on PLC will command the electro valve to open, which will relieve pressurized air. This will cause water to flow back into the first tank, in turn rotating the blades of the hydro turbine, which will generate electricity. Now, the pressurized air relieved from the valve will be taken advantage of by improving or optimizing the efficiency of diesel generator by making its combustion complete. And this will, in turn, reduce its pollution and fuel burn. Another way we can benefit from this pressurized air is by optimizing the efficiency of the fuel cell as well. A little demo of the recovery phase. So the voltage is controlled in such a way that, the airflow is controlled in such a way that the power is constant at the load. Now, as we can see in the first graph on the left, a higher pressure yields in better efficiencies in the combustion chamber of a diesel generator. To add to that, a higher pressure also decreases the CO emissions in these generators, which implies that it optimizes the efficiency as well as reducing the pollution of the diesel generators. And on the graph on the right, we can see that a higher pressure also yields in better efficiencies in fuel cell, as it increases the voltage by 67.5 millivolt per cell and reduces the power consumption of a fuel cell system by 20%. So we use V over F equal constant control method of the air compressor motor because when the irradiance drops, the motor will stall. But with V over F equal constant method, we control the frequency, hence the speed of the motor, in such a way that the torque stays constant. So by maintaining the torque constant, the air compressor will keep running and injecting air into the tanks even at a lower rate. And for the future, we will work on V over F inversely proportional to frequency method, which yields in a higher torque actually, and maintains the slip constant as opposed to V over F equal constant method, which increases the slip and, in turn increases the losses. As far as safety is concerned, the IEC characterizes two types of earthing, with galvanic isolation and without galvanic isolation. So, and we have two types of galvanic isolation. We have the functionally earthed system, and that means that a live part of the PV plant, the plus or minus, will be earthed along with the metal frames. The metal frames are always earthed, and the isolated PV generator will not have a conductor earthed with the system. So in case of isolated earthing, we have an installation monitoring device which will trigger an alarm in the case of the first fault. And the first fault won't cause a problem, but the second one will cause a short circuit. NEC code also mandates the use of arc detection device. Now for the without galvanic isolation, only metallic frames are earthed, so we have also a residual current breaker on AC side of the PV plant, and this breaker should be of type B as the standard recommends. However, some type of solar panels will have a corrosion and degradation, which implies that the use of galvanic insulation is better. The external lightning protection system will be composed of air termination rods connected to the mesh or ring earthing to inject the lightning into this earth via down conductors. The height and separation distance of these air termination rods will be determined by the rolling sphere method or the angle method. We also installed a safety valve in our system to ensure mechanical safety, which will relieve pressurized air in case it reaches a predetermined threshold. We used, of course, IEC, FAC, and ISO standards, especially residual current circuit breakers on the AC side of the power conversion unit should be of type B. This is the IEC's 60364-7 standard, in addition to recommended standards for waterworks and other standards. We faced some constraints during our project, mostly non-technical, like the manufacturability, local supply, and economical constraint, which we will work on in the future. And we can finally sum up by saying that our project offers a solution for both problems mentioned earlier by implementing it because it has a long lifespan and is cheaper, which makes it a clean and feasible, reliable solution for renewable energy sources, and this will encourage their implementation in Lebanon. And on the other hand, it will help complete the combustion of the diesel generators, and that will optimize their efficiency, reduce their pollution emissions, and the fuel burned at the end. These are the references. Thank you so much for your attention.
Sorry, anybody has any question? Okay, thank you. No, because they will be mixed. Okay, I invite Mr. Abbas Hijazi, Group C. Mr. Hijazi, can you just, who is your supervisor and which university?
Hello everyone, I'm Abbas Hijazi in Beirut Arab University. We were supervised by Dr. Nagam Ismail and engineer Hassan Gharib.
I give you. Yes.
Hello everyone. It's my honor to be here presenting myself. I'm Abbas Hijazi, and I will be talking about the safety related to wind turbines. And about the solution, my partners Amir al-Mughrabi, Sadiq Mugharbel, and Zamzam Hijazi and I proposed concerning the topic. As you all may know, electric power is generated by the means of wind turbines. And as you all may know, wind turbines are considered as an efficient energy production sources as well as green energy producers. But they might threaten the environment by the resulting hazards such as failure, collapse, and fire. And the images here show you well the problems that were faced in our research. Now let's talk about some facts concerning the residential wind turbines, which are the minimum height of the tower is about 30 feet and the maximum height is about 165 feet. The blade length...
Sorry, just if you put the microphone next to your mouth, because the translators are not able to... Thank you.
The blade length ranges between 4 to 50 feet, and the minimum cost is about $48,000. And as you can see in this graph, the wind power is affected by the tower height. Now, let's identify the problems we're facing. First, a recurring problem with wind turbines is that they tend to catch fire, where an average of 118 wind turbines catches fire each year. Another problem is that wind turbines collapse and thus threaten the environment and neighboring citizens. And finally, an average of 14 workers from the maintenance team fall from the top of the wind turbines annually. Now let's look for the solutions suggested in the literature. Automatic fire suppression systems are currently available for wind turbines, and hydraulic systems are used to push down horizontally the commercial wind turbine towers, as you can see in this image. Now let's talk about the solution we propose. First, we propose placing a fire system in the nacelle of the wind turbine, and second, controlling the tower's length by the means of a hydraulic system. And finally, placing a metallic plate on the tower. So as you can see, this is the design, and the lower part is contains the hydraulic system in addition to the plate, and the upper part contains the wind turbine with the blades. So our design combines the two solutions that are currently available and discussed in the literature, in addition to some improvements. Now, how does the design work? First, as I mentioned before, a detection system, in addition to a fire system, is placed in the nacelle of the wind turbine, where a thermistor is able to detect the temperature of the motor. When the temperature of the motor is high and increases to a very high value, the hydraulic system is activated and the powder cabins are open, and thus the fire is suppressed by the means of the powder cabins, and the tower will move downwards to a lower altitude. So when parts of the blade fall on the ground, they will fall in an enclosed area. On another hand, when maintenance is needed, the hydraulic system can be activated and the wind turbine will move downward also for a better and safer maintenance process. Now let's talk about the description of the fire system. A thermistor is placed on the motor where it records the motor's temperature and its resistance varies accordingly. Another resistor with a specified resistance is connected to it. When the temperature increases, a voltage is elaborated. This voltage is transmitted to the transistor and starts it up, and thus causing the coil to work. Therefore, the hydraulic system is activated and the fan of the wind turbine can move to a lower altitude. Specifications of our designs. First, fire is suppressed by the means of the fire system, and in the case when fire isn't suppressed, falling bodies from the blades are captured by the metallic plate placed around the tower body, and thus protecting the surrounding from damage and fire. Maintenance processes are carried out in a safer and more comfortable environment, since the maintenance team are able to control the height of the tower, and they are protected by the surface supplied by the metallic plate. Okay, now I'll sum up what I've been talking before. We have three problems, which are fire and parts of the plate collapse during fire, and finally workers' death. For the fire, we're able to solve this problem by the means of the detection system, in addition to the fire system, which are placed in the nacelle of the wind turbine. Collapse of the blade parts are captured by the plate placed at the bottom of the tower. And finally, workers' death, hydraulic system is able to move the tower to a lower altitude and thus ensuring a safer and easier maintenance process. And also the hydraulic system is able to control the height of the tower when migration of birds when there is a migration of winds, of birds. Thank you for your attention.
Is there any questions?
No.
Thank you.
Thank you very much.
You. Now it's a Group D, Mr. George Elias. Hello, Mr. Elias. Who is your, just if you can say who is your supervisor?
Hello everyone, my name is George Elias. My instructor is Dr. Bshara Nami. I'm from USAC, third year electrical engineer. First, I need to thank FISUEL and the Federation of Lebanese Engineers. I will talk about problems in wind turbine, what are eddy currents, electrical braking system, and the future plan. No one is perfect. So of course, all the products aren't ideal. What are the problems in the wind turbine? Electrical problems, mechanical problems, high maintenance, and fire is a common problem in wind turbine. The causes of fire in wind turbine are lightning strikes or mechanical braking system. What are eddy current? I will talk briefly about it. So if we have a coil and we give that coil a current, it will induce us a magnetic field. And if we have a conductive material next to that coil, and that conductive sheet is moving, so we will have an eddy current field. And that eddy current field, if the magnetic field of the coil is rotation is clockwise, so the eddy current force will be counterclockwise. That's how the eddy current works. Wind turbine components. Mainly we will talk about the rotor, low shaft, and the high shaft. And the mechanical braking system is on the high shaft. The ratio of the wind turbine is 1 to 90. So if the speed is 1 RPM at the low shaft, it will be 90 RPM at the high shaft. I did a small prototype, just a proof of my concept, how it will work. I use a coil next to the low shaft. Why next to the low shaft? Because, for example, if I need to reduce the speed 90 RPM, I will reduce it 1 RPM at the low shaft, and it will be 90 RPM at the high shaft. I give current to the coil. I put non-magnetic material in the rotor, and the rotor is moving, so there will be an eddy current field. My future plan about this product is, of course, I will use a PID controller to control the current that I need, an IVR and a relay. The sensor will send the speed to the PID controller. The PID controller will talk to the IVR, and the IVR will send us the current that we need to the coil. For example, if the speed is 60 RPM, and there is a wind storm, the speed will be 65 RPM, for example. I need to reduce it to 60 RPM. The sensor will send to the PID controller that the speed is 65 RPM and I need it 60. So all I need is 5 ampere, for example, to slow the speed to 60 RPM. But if the speed is 65 RPM, so I will need more current. So the PID controller will talk to the IVR, and the IVR will send us more current to the coil that I put on the low shaft to decrease that speed from 75 RPM to 60 RPM. And thank you so much.
Thank you. Yeah, any questions? Okay, now it's a group E. Ms. Mariam Kahloun.
I am Mariam Kahloun from Lebanese International University. I worked on the project of solar cooling, heating, and electricity generation for a residential building under the supervision of Dr. Mustafa Gadirab. This presentation will include an introduction, literature review, proposed system, results, and conclusion. First of all, the idea of my project starts from our lifestyle and our suffering in the energy sector in Lebanon. The first reason is the shortage of the non-renewable energy sources. 87% of gas emissions are from the thermal power plants, as the global climate analysis records. The power demand is higher than the generation, as EDR report, and the deficiency is about 1,450 megawatts. The cooling and heating system assumes about 55 to 70% of the total electrical demand. First of all, let's have a brief summary about my project. The project is being located in the southern coastal region of Lebanon, in a village called Saksakiye. Why I chose the coastal region? Because the highest population is being in this region. We split our work into two parts. The first one is the passive, and the second is the applied. We highlighted on the passive cooling and heating system to reduce the cooling and heating loads. For example, the usage of double glazing and even the color of a glass itself can reduce a lot in loads. Second is the shading. Third is the blinds and curtains. Although these auxiliaries are decorative, but they have a great effect in reducing the loads. And finally is the heat-resistive wall, is the double wall using a resistive material like cork or just keeping an air gap. For the applied cooling and heating system, my target is to reach the comfort condition in which, in summer, the condition zone should be retained at 24 degrees Celsius and 50% relative humidity. And in winter, the temperature should be 22 degrees Celsius and 30% relative humidity. As an overview of all the available systems, first we'll start with the vapor compression refrigeration cycle. It is the commonly used system. It consists of compressor, evaporator, condenser, and throttling valve. The second and the third are the absorption and adsorption systems. These systems are characterized in which the vapor compression refrigeration cycle, the compressor in it is being replaced by a chemical thermal compressor. And finally is the desiccant refrigeration cycle. From its name, this system is being based on a desiccant material, just like this material I have in my hands. We will discuss it in the next slide. Heating systems, furnaces, boilers, heat pumps, and electrical heating are well-known systems. Solar heating system is the system that we will discuss in the next slide. For the proposed system, why I go for solar? First of all, Lebanon is located in the high irradiance region as the solar GIS maps. Humidity is a crucial thing for cooling system, in which in Lebanon the relative humidity can reach 90% in the coastal region in summer. Let's have a brief summary about our system. First of all, this system composed of desiccant wheels, rotary heat exchanger, and indirect evaporative cooler and air-water heat exchanger. The ambient air will enter a point 1 with a temperature at peak conditions about 40 degrees Celsius and 90% relative humidity. The three wheels are capable to remove the moisture from the fresh air. At 0.6, this air will have a target relative humidity, but the temperature is still high. Just a note, between 1 to 2, this process is exothermal, so there is a heat rejection. Because our system is an energy-saving system, we took advantage of this heat to heat up a water that will be used later. So, at 0.6, the air has the target humidity, but the temperature is high. In the rotary heat exchanger, the upper stream is hot and the downstream is cool. So once this wheel will rotate, there will be an heat exchanging. In the indirect evaporative cooling system, this system is based on water as a coolant. We will have first stream of air, and the water will be passed perpendicular to it, so cooling will occur without affecting the humidity. In the return stream, at 0.11, the air will be hot, but I needed to heat it up more to reach a regenerative temperature. This regenerative temperature for this material is about 70 degrees Celsius. Can you imagine the silica gel as a ball? In the first stream, this ball will be filled with water, and it is now in the downstream. Once temperature is 70 degrees, this desiccant will return to its initial size. So this cycle will be repeated. For the solar heating system, in the coastal region, the summer is tough, but winter is moderate. So an air-liquid heat exchanger is enough for us because the heating load is about 9 kilowatt, while the cooling load was about 27 kilowatt. For energy-saving target, we mix the ambient air with return air because the sun irradiance in winter will be low. For the photovoltaic system or electricity generator, we use solar panels, charge controller, inverter, batteries, and net metering technique. As a result, for the desiccant cooling system, it will offer for me the 27 kilowatt that I have been calculated before. I'm in need of 3 desiccant wheels, 1 rotary heat exchanger, air-water heat exchanger, indirect evaporative cooling, small fans, and pumps. So, for a note, the only rotating parts in my system are small motors and small fans and small pumps. So this system doesn't need a lot of power. And for solar heating system, I need air-water heat exchanger, some fans, small pumps, and the area of the collector will be 10.7 meters squared, while the area of the collector for cooling is 5. And for solar electricity generation, I need about 180.5 meters squared, noting that the total area of my studied building is 227 meters square. Now, this is the results. I do energy-wise and economical-wise. For energy-wise, what are the characteristics of my system? If we can, for comparison reasons, we took a similar or equivalent system for my system that used split cooling system. We found that 83% in the cooling system there will be energy savings, and 87.7% will be energy saving for heating system. Economical point of view, although the capital cost of my system is a little bit high, but the operating cost can do a difference for both cooling and heating system. For PV system, we found that the payback period is about 7.5 years, and this number is compatible with the number that on Tuesday, the FISUEL presentation offered is 7.3 years. Finally, demand is greater than the generation, so an alternative solution is necessary. Shortage of the non-renewable energy We have a lot of solar renewable energy in Lebanon, as Lebanon is characterized by 300 sunny days, as UNDP said in reports. This system doesn't need high temperature or high pressure as the thermal power plants. No emissions and low operating costs, low noise, no noise, odorless, and eco-friendly. Think smart, think affordable, think green. Above them all, think about Lebanon. Thank you.
Thank you very much. Is there any questions? Okay. Sorry, just.
Sorry. Is there any application, any similar application, but for a bigger building? It's for
residential,
house,
yes.
Residential house. Is there a similar application, but for a building, for example, with many story?
In fact, this system is a new technology. The only research we found is the small desiccant wheels. This is the proposal of the first bigger system, but the NASA Center or Burj Khalifa in Dubai, they use the desiccant wheel before the standard split unit because it reduces the power on the compressor. But there is no significant or research that is done for bigger research,
actually, it's for small
It is applicable, of course, for bigger scales, but I think it needs a plant near it to power it because it needs a big area a little bit. But it is applicable for all, for smaller scale or bigger scales, it can be applicable.
Thank you.
Any other question?
Thank you so much. Yeah. Mr. Muhammad Ali, Group J.
H ou G? J. Oui. Ben, je ne l'ai pas, celle-là.
Allô?
Non, c'est la L qu'on a donnée. C'est G? This one, J? Ah, mais celui-là, le H. Oh, okay. Le G, le H ne vient pas. D'accord.
Hello, my name is Muhammad Ali from Islamic University. My name is Muhammad Ali from Islamic University. My supervisor, Dr. Walid and Dr. Jamal Haidar. Our presentation about artificial intelligence platform to increase the performance of the solar cell. The outline. Now we talk about. Sorry, this old presentation. What? This old presentation, not new.
You have to see that with. Les problèmes du direct. No, you can't. Leave it to me, please. The direct problems. Don't break my computer. This? Where is it? Which? This? It's exactly the same as you think. It's not the GA. Yeah, I will. Je préfère mettre là et je vais l'ouvrir direct. I will open directly. Take. Remove this.
Sorry. My name is Muhammad Ali from Islamic University of Lebanon. My supervisor, Dr. Walid Fahas, and Dr. Jamal. We talk about artificial intelligence platform to increase the performance of the solar cell. Outline introduction. We use the artificial intelligence neural network to solve the dust problem on the solar cell surface by depending on the factor that reduce the performance of the solar cell. The main problem of the solar cell reduce the performance of the dust. Now we see this test. We make it in minor university. We see the different voltage between the clean and unclean surface, but we see the March and April we have less voltage. That means we have more factor to reduce the voltage to performance of the solar cell. This factor is temperature, humidity, and voltage and weather. This chart shows the different the effect of the voltage on the solar cell. The high temperature, that means we have reduced the more voltage, and also the humidity. The high humidity, we have reduced the voltage. And weathers, you classify the weather to 3 types, depending on the lighting. The first, sunny is good, partly sunny is bad, or rain, or another type is very bad. We have to work on the neural network. We have system to predict the weather because we need to use this system without internet, in any place. We have big data to 5 years ago to weather in Lebanon to predict the weather. This data we use in artificial intelligence neural network. Artificial intelligence neural network, computer system, similar to the human neural system to work to make this decision. Methodology, artificial intelligence system to predict dust on the solar cell. The neural network have 3 layers: input layer, hidden layers, and output layer. This system predicts the voltage in this time to comparison with voltage from the solar cell to this. And now to comparison with voltage. If this voltage less between 10 or 6% from voltage system of the solar cell, the system take decision to clean or not. We have a 3 input. We have a 3 input value: the weathers and temperature and humidity. This effect on the voltage on the solar cell to reduce the performance. And hidden layer to calculate this effect and output give us the predict voltage. If this voltage, less voltage came from the solar cell, the system clean this surface. This test, we apply this system on Arduino or Raspberry Pi and test it in MATLAB. This result, rent error 0.25. The bubble chart you show the similar in MATLAB. This advantage of this system, we have less use water, automatically management, less energy, smart, and remote management. Conclusion, finally we found if you not clean the solar cell for the month, the solar cell reduce the performance to 50% of the total value. Thank you. Any questions?
Do you have some questions to him directly? No. Thank you.
We have Group L now, 3 speakers. Ms. Rawan Al-Halabi, Mr. Tariq Abdul Fattah, and Ms. Subhiya Hajjar.
Okay, good afternoon all. My name is Tariq Abdul Fattah, and these are my colleagues, Rawan Al-Halabi and Subhiya Hajjar. We will be presenting Sustainable Greenhouse. We are from Beirut Arab University, and our project is supervised by Dr. Muhammad Khamis Mansour. Okay, a greenhouse is a structure usually used to provide the suitable atmosphere for plants to grow all over the year. Also, it is used to protect the plants from excessive weather conditions in winter and in summer. Okay, the problem statement, it comes from the principle itself. The sunlight, which is a short wave, penetrates the plastic or glass cover of a greenhouse. After that, it will be absorbed and reflected by the soil and the plants. However, it will be converted into long wave infrared radiation. That radiation cannot escape anymore from the greenhouse, and the heat will be accumulated so that the temperature inside the greenhouse will be increased. This increase is actually increase above what is desired, so it will lead to burning of the plants and drying their roots out. For examples, and according to garden guides, if we take 2 examples, the first is tomato, which must stay between 75 and 85 degrees Fahrenheit during the day and above 60 degrees overnight. Another example is the lettuce, which does not exceed 70 degrees Fahrenheit during the daytime and should stay above 45 degrees during the night. The conventional solutions used before for this problem is to ventilate the greenhouse either naturally by circulating the water, opening a door or a window, or by ventilating using a fan to increase more the heat transfer coefficient. Another solutions include the use of shades to cover parts of the roof so that to decrease the solar penetration inside the greenhouse, or cooling with water, evaporative process, or watering the plants more in order not to dry their roots out. However, we will, in our design, we will make use of this heat inside to generate multiple benefits in both cold and hot weather.
Okay, so for hot weather design, our greenhouse is a rectangular. Our greenhouse is a rectangular prism with a slanted rooftop, where 60% of its area is covered with photovoltaic cells that are linked to a control system. So when the sun strikes high, they provide shade for the plants to prevent them from burning, whereas in cooler weather, their angle automatically changes in order to allow only an adequate amount of sunlight to reach the plants. These PV cells don't only provide shade for the plants, but they also convert solar energy into electricity that is stored in batteries. And at nighttime, these batteries light the lamps inside the greenhouse, so they provide both heat and light for the plants. So the photosynthesis process continues, and the plants grow faster, so that is more profit for the farmers. These PV cells, however, do come with a problem that their efficiency is already very low. It's approximately 15%, and it decreases by 1% as the temperature increases by 4 degrees Celsius. So they require a cooling system. For that, we designed an outer cover for our greenhouse where cool air enters from this side under the PV cells, cools them down, and then now we have hot air. This hot air is, as we know, can endure a lot of moisture, more than cool air. So we inject it with saline water moisture, water vapor, and then this hot, humid air, accompanied by exterior air, enter into a cooling coil where we obtain freshwater condensate. This is the desalination process. And then into the greenhouse enters cool, humid air, perfect for the plants. Its temperature and humidity both increase, and then they enter into another cooling coil where more fresh water is obtained. Part of this air is recirculated, whereas the other part leaves the cooling coil. Our main components are heat exchangers of efficiency 60 to 70%. They do both air conditioning and help in the water desalination process. The lamps help the photosynthesis process to go longer. The PV cells have an efficiency of approximately 15%. They provide both, shade and produce energy. Finally, the air washers, they humidify the air, and they also aid in the desalination process. As for the constraints of this design, PV cells are expensive. Their manufacturing process does produce some toxic emissions into the atmosphere, and the solar energy sometimes is inconsistent. Thank you.
Okay, now let's talk about cold weather design. In cold weather, we will use windmill to secure power generation, which is used to power the lights inside the greenhouse. If the heat provided by the lights was not sufficient, we have to implement an external heating source. In this external heating source, we will use a finned tube heat exchanger to heat the air that will be blown into the greenhouse. The hot water used to heat the fresh air is heated through the exhaust smoke of the diesel generators located in the area of the greenhouse. So as we can see, this is the smoke of the diesel generators. We can use it to heat the water stored in this insulated tank. Then part of this water is used in the heat exchanging process to heat the air entering the greenhouse. If the temperature inside the greenhouse is perfect and there's no need to increase it, then you can use the water stored in this insulated tank in the membrane distillation process for salty water, where salt is separated from water, and then you can use this regular water for many stuff such as irrigation. So cold weather design is based on three main components: the windmill that converts wind power into electricity, the membrane distillation that desalinate water, and the waste heat reclaim that provide hot water for heat exchanger or membrane distillation. Cold weather design has some constraints. Windmills are somehow expensive and create noise. In addition to that, membrane distillation control is not exact. About requirements, windmills require large area and an airspeed between 2 and 25 meters per second, and membrane distillation requires low pressure. Based on a study we made on a greenhouse with an area of 12.8 meters squared, we conclude that the cost will be approximately $8,500 and the payback will be in 2.4 years. Finally, the outcome of our system are, first of all, more efficient agriculture, usage of renewable energy, water desalination, higher profit, decrease in pollution, and finally, exhaust heat recovery. Thank you.
Thank you. Do you have questions to them? Yes, one here.
Hello and good luck in your projects. I have a question for all students about all projects. You know, project finally, it's an idea, it's experience, something like that. After you find all presentation about your projects and other students, did you find some integrated points, some added value to your projects and for others also?
Yes, we did actually. Beirut Arab University, the B campus, they used that battery, the hydraulic pneumatic battery. It could be used for the solar panels that we use. So a combination of the projects would be of our benefit, of course.
And what about other students?
I'm from Al-Ayyub. My belief that the big scale project can cost enough, I believe in a quote that say the journey of 1,000 miles started by a single step. Because of that, my project was for residential building, which it can be economically effective.
Okay, so after observing other projects, I think that we can work on an integrated solution that can combine more than one project, because as we can see, we have several types of energy efficiency and savings, which will produce actually a great project if they are combined together. Thank you.
Sorry. أنا بالنسبة للمشروع تبعي عن ال Artificial Intelligence أكثر من هو بريدكت على الداست اون ذا سولار سيل. هيدي المشكله اللي احنا فتنا فيها وطبقناها على سيموليشن بس، وبنفكر باحنا نطبقها على الاردوينو او اي راسبيري باي او اي ديفايس ثاني.
Thank you very much. Stay here, please. Is there any question now? No, thank you. Then now, I would like to, with all of you, to felicitate all of the students. Yes. Come, all of you. And with the doctors also, if all of them are here. The doctors.
Can I invite the doctors and supervisors to come and have a photo with the students, please? No one is here?
No, nobody?
Dr. Bshara is here.
Okay.
Dr. Bshara. Thank you.
Thank you very much.
Dr. Shadi is outside. Dr. Jamal, can you call Dr. Shadi also for the photo?
Just to remind, they worked during 3 months on their project, with help with their doctors and managed by Habib. And for that, a big, big applaudissement. As all competition, there will be a winner. That's for that. I invite the people of the jury. You are here, and that you have to go with Habib at the first floor in the room. Yes, working groups. During this time, we will have the possibility to take photos and va vite travailler. We will take photos here. Let's go for photos. After we have time to go behind to see the project of each groups. We see... Non, photos. Eh ben, je suis pas avec vous, moi. One with me. One with me. Eh non, il faut que j'explique. we have half an hour to visit the project behind, and after I will arrive. And after you have also the sponsors beside, and at 1:30 we have all together students also the lunch just behind this wall. That's right? No mistake, Jamal? Okay, thank you very much. See you at 2:30. What time is it now? What time is it? 1 o'clock. That's okay. At 2:30, it's 2:30 p.m. in the room for the continuity. Thank you very much. With together. If you want. Ok, on va voir les...